ever wondered why an ambulance sounds different when it passes you by? Or why things are certain colors? Or what is happening in the greater universe? Would you believe me if I told you we can begin answering all of these questions with the same concepts? Well, let's see. To begin, we must start very small. Like every person, every element has its own unique fingerprint. These fingerprints are shown through light by a study called spectroscopy. This fingerprint comes from elements absorbing certain wavelengths of light. The ability to do this is tied to specific amounts of energy the electrons of each atom require to shift energy levels. Those shifts are the absorption of energy and can be shown through absorption spectroscopy. We can then use those unique absorption patterns to determine what elements we're looking at. The wavelengths of light absorbed correspond to colors of visible light, and the colors that substances don't absorb but instead reflect or transmit become the color that substance takes on. Cool, right? But how does this relate to space and ambulances, you might ask? Well, in the 1920s, astronomers were looking at distant stars, nebulae, and galaxies to see the absorption spectrums of their emitted light. That's when astronomer Edwin Hubble noticed something that would change how we understand our universe. But before we get into that, here come the ambulances. If you've ever had an ambulance driving by you, you have probably noticed that the pitch of the sound changes when it passes you. This is the result of a phenomenon known as the Doppler effect. It is caused by sound waves compressing or expanding. As the ambulance approaches you, its sound waves compress, and the wavelengths of those sound waves shorten, increasing its frequency and thus producing a higher pitch. Whee! Inversely, when an ambulance siren is moving away from you, its wavelength is longer, and its frequency lower, thus producing a lower pitch. Whoo! Interestingly enough, this same effect occurs for light. When something is moving closer, its wavelength shortens, and when it's moving further, it lengthens. As wavelengths of light are related to different colors on the visible light spectrum, this can actually be seen through spectroscopy. If something has a shortened wavelength, it is more towards the blue end of the spectrum, and longer wavelengths are associated with the red end of the spectrum. As something moves towards you, the absorption spectrum from its light shifts towards blue, and when it's moving away, it is considered red-shifted, as it shifts towards red. Now you remember Edwin Hubble's big discovery? Well, this is it. In 1929, Hubble observed that the absorption spectroscopy from distant galaxies was in fact redshifted. Thus, he proved that our universe is actually expanding.